Remember we have done these ones, right?
Yes, sir.
Yes, we have done those, and I've explained to you those. So we have done systematic random sampling, whereby you need to find the value of k, which will be the interval, and you will be given a starting point. However, like I mentioned, when it comes to systematic random sampling, then we usually randomize, we actually pick a number at random to be our starting point. But like I mentioned, different calculator will give different starting points because of the randomization that it has. So in our case, I will be providing you with the starting point so that everybody can be on the same wavelength. Now, if you notice, we did some examples, like I said, and especially like these two at the end, whereby when we are adding the interval, we realize that it falls beyond the sample space. Like in this case, we have 233, and if we were to add 20, it will give us 253, which is beyond 240. So what we need to do is to see how many people that we have remain to reach 240 from 233, that would have been 7. And then how would we get 20%? We need to add 13 more. So 13 will be the other number that will be there. So what we will be looking at will be stratified random sampling. Let me see. Yes, good afternoon. Yes, good afternoon. What is it? Who? No, not at this moment. Sorry about it. Okay, welcome. Okay, sorry about that. Students, let's continue. So, we have looked at all of these things. I hope you're studying because I'll be sending some work today. Definitely so. So, we're going to be looking at stratified random sampling. And I told you that in stratified random sampling, what we do is usually we take our population and we're going to be splitting the population into distinguishable layers, or what we call strata, and the singular form is stratum. Okay? So let's say, for instance, looking at Central Escolameco Junior College, and we would want a sample that would represent SEMJC to go out to represent everything that we have. So we need to look at the students, 1 and 12. We need to look at the administration. That's a different strata. We need to look at the cooks at the cafeteria. We need to look at the security. We need to look at the janitor. So what we need to do there, even though that's a population, SMJC is a population of its own, but then it has been broken up into different strata. Okay, because we have teachers, administration, students, janitors, cooks, security officers. So if we were to take a sample and not taking everybody, then let's say SMJC has 460 students. I mean individuals. The population is 460 with administration, with teachers, everybody. Then remember, the teacher has a smaller population than the students. Admin have even a smaller population than the teachers. We have certain cooks, we have certain number of security. And let's say out of the 450, they want 20 samples from that. Okay, the sample is 20, which means that should include admin, teachers, students, the people that work at the cafeteria, and the security officers. So this is where stratify random sampling comes in. In order, we select what we select in distinguishable layers to ensure that everybody has a fair chance from each section to be selected. Now here we have some example. You have age group. Like for instance, if you would like to see how the COVID is affecting, for looking at age ranges, maybe you might say, okay, let's see from 1 to 5 years, and then you split it as 1 to 5, and then 6 to 12, and then 13 to, let's say, 19. So what you have done there is to split it in stratas or in layers. Then occupational group, like I just mentioned to you at SMJC, your occupation is a student, then mine is a teacher, we have administration, the dean, and so forth. Then we have topographical regions, yes, as well. We can split it in different interdistinguishable layers there. Now what we will be doing is to look at some example of stratify random sampling and see how it works. Now, the first example that they gave here, it said that competent carriers employ 320 drivers, 80 administrative staff, and 40 mechanics. A committee to represent all the employees is to be formed. The committee is to have 11 members, and the selection is to be made so that there is as close a representation as possible without bias towards any individual or groups. Explain how this could be done. Now, competent carriers is the company there, and they have employed 220 drivers, 80 administrative staff, and 40 mechanics, which constitute competent carriers. Now, what I did here, I used a capital D to represent the drivers, a capital A to represent administrative staff, and a capital M to represent the mechanics. So the number of drivers that we have, this is the cardinal of the number of drivers, 220. The number of administrative staff, 80, and the number of mechanic is 40. Now together, the sample space will give us the total population, including driver, administrative staff, and mechanic, will be 440. Now, out of that 440, they need a sample of 11. But that sample of 11 must constitute of drivers, administrative staff, and mechanic. So what you do after you have added all the different strata, which is 420, you will take each stratum and divide it by the population, which is 440, and you multiply to the sample that they're asking you to get. So out of the 320 drivers divided by 440, which is the entire population, times the sample will give us 8. So if you put this in your calculator, 320 over 440, so you will be selecting 8 drivers out of the 320 that will actually make up the sample of 11. Then from there, we look at the administrative staff, they are 80. Out of the total, again, 440 times the sample, we get 2. So out of the 80 administrative staff, we will be selecting 2 from those. And then the same thing goes for the mechanic. Out of the 40 mechanics, for that sample, we're going to be selecting 1. And if you notice, if we were to add 8, 2, and 1, what do we get?
11. 11.
Okay, 11. And 11 is what?
The sample.
The sample that we are looking
That's the sample.
Yes, that's a sample. Very good, because it's a committee to have 11 members. So that is the sample. They want them to have 11 members. So competent care needs to employ 8 drivers, 2 administrative staff, and 1 mechanic. So are there any questions based on this example?
No, sir.
Then here I have a second example. It said a school of 1,000 pupils, they already gave you the total, is divided into a group as follows. So we have year 7, year 8, year 9, and year 10 and 11, each having 150 pupils. Then we have year 12 and year 13, each having 125 pupils. Now, if you were to add from year 7 to year 13, this amount, they should give you the population that they gave you here, which is 1,000 pupils. So already you have the population. And here you have the different numbers for each stratum. However, if you notice from year 7 to year 11, which is basically 5 years, they have the same number of people. So rather than doing this 5 times, and I won't be penalizing for to do 5, some people say, okay, year 7 equals 150 over 1,000 times the population, the sample, which is 40 here, because it said a survey is to be carried out and a committee representative of the school is to be formed consisting of 40 people. It is decided that stratified sampling should be used. Calculate the number of people chosen for each year group, and be explained to choose the people from year 7. So from that, they want us to actually form a committee that will have 40 people using stratified random sampling. So like I said, you could have done it individually. For instance, 150 divided by 1,000 times 40, then year 8, 150 over 1,000 times 40, and each of them will give you the same answer. So in order for you to expedite the process or to save time, then you can do from year 7 to year 11 one time, and then you can do 12 to 13 one time. But just remember how many 150 there's 1, 2, 3, 4, 5, and how many 125 there are 2. And together they should make up 40 individuals. So let's go to the calculation. So if you notice that the sample size was 1,000, the population was 1,000, the sample was 40. So what I did is from year 7 to 11. So I said year 7 to year 11, which include 8, 9, and 10, is equals to 150 over 1,000 times 40 equals 6. So which means then that 6 people will be from 7, 6 will be from 8, 6 will be from 9, 6 will be from 10, and 6 will be from 11. And because those are 5 different strata, I multiply 5 times 6, which gives us 30. So we already have 30 individuals for the sample. Then we take the 2 125 and we do the same year 12 and year 13, and it's 124 over 1,000 times 40, we obtain 5. But because it's 2 years, then we multiply 5 by 2, and then that will give us 10. Now, if we add 30 and 10, we will get the sample that we wanted, which is 40. So, in other words, like I said, nothing wrong if you want to just do year 7 And then you're gonna be having this 150 over a total of 45 times. Because you will have it for year 7, year 8, year 9, year 10, year 11, and that's it. And then the same thing here, you would have it for year 12 and year 13. So that would be too much working. So you need to look at problems like these two that to facilitate, all right? And so forth. Now, how would we explain how to choose the people from year 7? How did we choose the people from year 7 in words? Okay, said explain how to choose the people from year 7. How would we go about choosing those people from year 7?
Sir, would it be the total number of pupil, which will be 150, divided by the population, which will be 1,000, and then you multiply it by the sample, which is 40, and which will give you 6.
Very good. Excellent. So, first of all, you need to choose the number from year 7, the number of people from year 7, which is 150. Very good. Divided by the total number of people, which is 1,000, times the sample, 40, which will give you 6. Okay? Now, let's look at the last example here. It said a meat canning factory supplies a supermarket with cans of meat in 3 sizes: large, medium, and small. The regular consignment is of 300 large cans, 500 medium cans, and 400 small cans. Describe how the supermarket could apply the method of stratified random sampling to a sample of 60 cans to test the quality of these goods. So once again, like the first one that we did, we can use L to represent the large can, M to represent the medium cans, and capital S to represent the small cans. Then from there, we say that the number of large cans was 300, that was given. The number of medium cans, 500, that was also being given. And the same goes for the number of small cans, which is 400. And then the population, after we have added everything, will give us 1,200. If you were to add 300, 500, and 400, you get 1,200, which is 1,200. And they're asking here for a sample of 60 cans. So that would be the sample of 60. So that would be the sample of 60. Yes? Wait, check who the, right now, student. Right now. Okay, right now, let's continue. Okay, so the process, all of them followed a similar process. We take the number of large cans over the total times the sample, we obtain 15. Then we have 500 medium over the total times 60, that's 25. Small 400 over 1,200 times 60, that's 20. So if you were to add 15, 25, that's 40, and 20, that's 60. So from this consignment, the supermarket will assign 50 large cans, 25 medium cans, and 20 small cans. And 20 small cans. Everybody saw that?
Yes, sir.
Any questions? Are there any questions pertaining? Because this is the last example that I'll be showing with stratified, because all of them follow the same procedure, the same process.
Yes, sir.
Okay. Now we are finished with random sampling because we have looked at simple random sampling, we have looked at systematic random sampling, and we have looked at stratified random sampling. Now we need to look at the non-random sampling now. And remember, there are two non-random sampling, which I gave. Which are they? So we have two non-random samplings, and these are the two, cluster and quarter sampling. These are the non-random sampling. We have cluster and we have quarter. Now, it said here for cluster sampling, we divide the population into groups or cluster and then select a random sample of these clusters. It is assumed that these individual clusters are representative of the population as a whole. If a market research team is attempting to determine by sampling the average number of television set in a household in a large city, they could use a city map to divide the territory into blocks and then choose a certain number of block clusters for interviewing. Every household in each of these blocks would be interviewed. A well-designed cluster sample project can produce more precise sample, all consuming low cost than that of simple random sampling. So cluster, as you can clearly see, you can take it whether you're living in a village or in a town. Let's say that you want to find out a simple thing. How many household owns an orange? How many orange trees each household? Let's say you're looking for 3 different fruits, like orange or grapefruit, and we have kinep, like for instance, crabo. Let's say that from your village or from your town that is what you are looking for. So let's say that 5 of you are doing that particular survey. So what they could do is to split the village into clusters, into five different clusters. Some cluster might have more people than the other, but the thing there, you just split it in cluster, and then each person can go there and find that information that you're looking for. And at the end, all 5 of you will come back together on the drawing board and do the analysis and see what is the true value that is happening in your village or in that town. So that's all about cluster sampling. Now, quarter sampling is a bit different than that, because here quarter means that they're giving you a number or something. If I said, okay, your quota is to interview 20 persons, you cannot interview no more than 20. Your quota is 20. Or your quota is to deliver 40 questionnaires and to collect all 40 back. Then that is a quota. It's a number given to you. So as soon as you are finished with that, and this is very quick and easy, and the complication is kept to a minimum, because in quota sampling, what can happen that you could usually change the person that, so it's a bit biased, you can usually change the respondents. Because remember, you are working with quota, you're just looking for a number of what you need to do, whether you need to submit, interview 10 individuals, or you need to find 20 houses that have children that are 3 years old. So as soon as you are done with your quota, that's it. And that's the reason when some cane farmers say, okay, this is my quota, 300 tons, meaning then that the factory will only allow that amount from you during the cane season, and you cannot supply more than that because that is your quota given. So it's something like that. So quota is different from cluster. Cluster, you split up in blocks, and then each person will go an interview, and excuse me. And from that they come together and analyze the information. But quota is very simple as long as you have completed the number that they have asked you to. And usually this has been used for street interviews and so forth. Are there any questions based here on quota and custom? You could read this on your own. I already explained the major difference that are there. Are there any questions?
No, sir.
Okay. Now today we will be moving into something new. Remember I told you that there are various or several ways by which statisticians can present their information. However, whenever collecting data, sometimes we mention that they tend to use tables as well. So here we're gonna be looking at raw data. Raw data is just when you go and you collect your information in a haphazard way, and then at the end you need to come back and put it in some sort of an order before you do your analysis as such. Then we're gonna be looking at on-group data. On-group data is like after you have done your raw data, you can take that information and present it as a frequency distribution table. Let's say that you are taking the different age range in your class. Then probably you can say that, oh, 0% have 14 age. Then we can say that, okay, for 15, 3% 15. For 16, 4. For 17, 1, and so forth. So you could put them in an order on group as a frequency distribution chart. But we will be doing those separately. But the reason that I discuss raw data and on group data together is because both of them do not lose their data fidelity. You know exactly of what each item you have, and you actually you do not need to make a guess of, oh, like in group data you will notice that it has a range like 1 to 5, 30. Who have 1 to 5 30s? But suppose between that number 2 doesn't have anything or things like that. But we're gonna be discussing those as we go along. But let's go into raw data. So I'll be saying, let's go into raw data. Okay, this will be a formula paper that I'll be giving you as well. In the case of raw data, let me go back here. Because what we will be doing, before I discuss what's happening, we will be finding the mean, the mode, the median, the lower quartile, the upper quartile, the interquartile range, G, the semi-interquartile range, and H, the standard deviation of the following. So this is raw data because that's what we're going to be looking at for the remaining part of this period. So we have the raw data. So all of these are raw data. Now, if you notice, the values are in haphazard form. So whenever you're doing any calculation, you must you must organize your data in such a way in order. And this will be in order of ascending size. So you begin from the smallest number to the largest number. Okay? And the numbers must be in numerical order from the lowest to the largest before you do any calculation. Even though only two things may not be affected here, the mean and the mode, when it comes to raw data, because the mean is just the average of the observation, so you can add it in any way and just divide by the total number of observations. So in this case, there are 11 numbers. Having add these 11 numbers, you divide by 11, that's the mean. They do not have any specific order. The same thing with the mode. The mode is the most frequent occurring observation. So you're gonna look which number occurs the most. In this case, it is 4. It's appeared twice. And what I want you to understand that in some cases, you could have more than, before we look at the calculation, I'm gonna explain that you can have more than 2 modes. Now let's get back to the, here. That VP, I'm just checking something that they sent for me. Okay, let's continue. Now, for our data, like I have said to you before we do any calculation, it is best that we rearrange whatever is being given to us in numerical order or in alphabetical order, starting from the smallest to the largest. But here we are dealing with numerical data, so we're gonna be starting with the smallest number to the largest number. Now you can clearly see here it said the mode is the value or values that occurs most often in a set of given observation. It is the most occurring observation. So looking at the raw data like the one that I just showed you, that 4 was the mode because that was the most occurring observation in that set of observation. However, like I had mentioned to you, there are cases that you could have more than one mode. So you must bear that in mind as well, that you could have more than one mode. Then in order for us to calculate the mean is the average of a given set of observation. And for our data, X bar means for the mean is equal, this sign here is the summation sign that looks like an E. That's a summation. That means the summation of X. This is how we the summation of X. Where X are the number of observation. So like the example I showed you, there were 11 observations. So X is the summation, so you need to have added all of those 11 and divided by the number of observation N. In that case, it was 11. We're gonna be looking at that example shortly. Now, in the case of the quartiles, we have the lower quartile, which is represented by Q sub 1, and the lower quartile is 25% of the distribution. If we were to look at an Ogive curve or a cumulative frequency curve, Q1 is 25% of that distribution out of the 100%. So we're gonna take 25 over 100, that is 1/4. That is how we got Q1. The median is halfway, which is 50% of the distribution out of the 100. So that will be 50 over 100, which is a half. N plus 1 value. And Q2 is used to represent the median. And for the upper quartile, we have Q3 is equal to the 3/4 n plus 1/8 value. So in this case, this is representing 75% of the distribution. You will notice that after we are finished with these quartiles, because these are exact values, 25, 50, and 75, but how about values that fall before 25, and those are between 25 and 50, and those that are between 50 and 75, and between 100 and 75. Then there's whereby the percentile comes in that I will be showing you a different, not today. So that will be a percentile that we will be looking at, whereby we could find any actual percentage from that distribution. Then we got for the standard deviation. The standard deviation is equal to the summation of x squared. So you're going to be taking all the x values, like that case you have 11, square each of them, and then add them up. Then that will give you the summation of the x squared value over n, where n will be the number of observations, which was 11, and then x bar will be the mean. This, right, will be the square of the mean, and then to simplify this, and you're going to get the standard deviation. So let's look at some calculations now. Virtual data. So we're gonna be looking at number one. Like I said, the instructions are saying find the mean, B the mode, C the median, D the lower quartile, E the upper quartile, F the interquartile range, and G the semi-interquartile range, and H the standard deviation of the following. So we are looking at question number one here. And if you notice, we have 4, 6, 18, 25, 9, 16, 25, 5, 24, and 8. Now, what was the first thing that I mentioned that you must do?
Arrange them in ascending order, sir.
Excellent. We should rearrange them in ascending order of size, starting from the smallest to the largest. And I have done this already with the other class, so I won't be doing work all over again. So I just gonna explain. So what we do, we rearrange them in order of ascending size. So we have 2 4s of 5, because these are the 2 4s you can see. We have 1 5, a 6, where is here, an 8, where is here. We have a 9, which is here. We have 16. We have 18, 20, 22, and 25. And if you notice, there should be each number is being accounted for. Because if you add all these numbers, you're gonna get 11. How many number of observation? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And that was what you have here. So you need to ensure that all the members that you have originally are listed here, but in order. So we notice that there is none that is missing. So we can now continue to what we are looking for. The first thing that they're asking us is to find the mean. And going back to our formula paper, it said the mean is the average of the observation. So, and once again, this is the formula for the mean. X bar is equal to the summation of x over n. So you need to identify your values by taking the summation of x. X is the number of observations that you have here. You need to add all of these. So if you take your calculator right now, what I want you to do, because you need to verify, you're going to be adding all of these 11 numbers. 4 plus 4 plus 5 plus 6 plus 8 plus 9 plus 16 plus 18 plus 20 plus 22 plus 25. And you will notice that all of these will add up to 137. So do that. I give you seconds to do that, or 1 minute, because so you should notice that it will be 137. I want you to follow up because so that you know to use your calculator.
Sir,
So you got it?
sir,
Yes.
what does the X with the line on top of it signifies?
This X?
No, the other one at the bottom of that.
Which one?
The X
This
with the
here?
line at the top.
Oh, that's mean the mean.
Oh. Thank
That
you.
is the symbol for mean. So whenever you see X bar, we are asking for the mean. X bar is the mean. It is different from this X. This is the summation of the observations. Okay? And N is the number of observations you have, which is 11. If you add up all these, if you add each observation, it is 11 observations that we have. But if we sum them up by adding each number together, you should get 147. 137. So did you get that?
Yes, sir.
Yes, sir.
Okay, so 137 is the summation when we add up all of these numbers. And N is the number of observations that we have. We have 11 observations. So the formula states that the mean X bar is equal to the summation of the observation divided by the number of observations. So that will be 137 divided by 11. Then we round it off to, because it's gonna be 12.4 something, but I round this one off to 1 decimal place to 1 dp. So the rounding off of this is to 1 decimal place, which is 12.5. So if you were to take 137 and divide it by 11, then you will see that you're gonna be getting to 1 decimal place 12.5. So do that.
Yes, sir.
Right? Because you're gonna get 12.47 or
12.45.
well, okay, good. And then when we round it off to 1 dp, then it's that. We should have put that there, not in 1 dp. Okay. So we have calculated the mean, which is the average of the set of observation being provided. So are there any questions pertaining to the mean?
No, sir.
Yes. Yes? No questions?
No, sir.
Okay. Let's move on to the mode then. So what would have been the mode there?
4.
How do we define the mode of for a set of raw data is the what?
The number that appears the most.
Okay, so which number appear the most in here?
4.
4.
4. Even though I have the answer there, but you could see it, we can go back. That will be 4 is the one that occur most frequently in the set of observation. Now, the other one is the median. Now, the median is Q sub 2 equals a half n plus 1 n at value. Now, I am modeling my work the way that I want you to do it. Because you need to be setting the formulas, and you will notice these are direct. There will be some that you need to apply. There will be problems that will be giving you the mode and asking you to find a missing number and all sorts of things. So Here it's just like a basically direct substitution. There will be much more one that you need to think. So the median, the formula is a half n plus 1 at value. We know that n is 11 because n is the number of observation that we had. And the median is being denoted by q sub 2. So wherever you see q sub 2 in any problem, you know we are referring to the median. Good. Do not confuse mean with median. Please, because the Hamadili and the goat probably might look alike, but they are two different species or two different sets of animals. You cannot confuse a dog with a cat. A cat is a cat, a dog is a dog. Okay? So, what I'm saying here, do not confuse the mean. The mean is the average of the set. This is the median. This is the centralized value that you are finding. So in this case, it's gonna be a half 11 plus 1 because n is 11 plus 1, that will be 12. Half of 12 is the 6th value. Now, having done the 6th value, that is not the answer yet. That is the 6th value. So we need to go back to our set of observation and identify the 6th value, going from left to right. So what will be the 6th value here? 1, 2, 3, 4.
9.
Okay, 9. So if you notice that 9 is the median, is a centralized value. And if you look, how many numbers are after 9? How many numbers? How many numbers are after
5.
9?
5, sir?
5. Yes, and how many numbers are before 9?
4.
You sure?
6.
5.
5. That's the median. Remember, 9 is the median. So we have to have equal number of observations after it and before it. So we have 5 observations here, and here we have 5 observations. 9 is a centralized value. It's a 6th value, 1, 2, 3, 4, 5, 6. So Q2 is 9. So this is your answer. Q2 is equals to 9, which is the 6th value. If you only give me the 6th value, that will be wrong and worse when you go and you find other things that you need to use the median for, because then 6 is far different from 9. So remember, this is the 6th value. Now let's find the lower quartile. The lower quartile is denoted by Q sub 1. Once again, n will not change. N is 11 plus 1, which is 12. So it's going to be 1/4 of 11 plus 1, which is 1/4 of 12, which is what? 1/4 of 12. The 1/4 of 12 is the what?
3.
Okay, so it's the 3th value. Good. So once again, when we go up here, you will notice that the 3th value will be what? 1, 2, 3. So what is the 3th value here?
5.
Okay, it is 5. So that will be Q1. So Q1 is equals to 5. Then we do the same for the upper quarter, is 3/4 of the distribution. So it's going to be 3/4 of 12, which is the 9th value. Then we go back here and find the 9th value, which will be what?
20.
20. So we go there and that will be 20. That's Q3. And remember, Q3 represents the upper quartile. So make sure that you know the different symbols representing the quartile and the median. So if I give you Q2, it means it's the median, Q1 is the lower quartile, and Q3 is the upper quartile. Then for us to find the interquartile range, probably you could write this down, even though I'm gonna be selling the interquartile range because I didn't put it on the formula paper, represented by IQR, interquartile range, is the difference between the upper and the lower quartile. It's the difference between the upper and the lower quartile. We found out that the upper quartile was 20 and the lower quartile was 5. So it's gonna be 20 minus 5, which gives us 15. That will be our interquartile range. Now, in order for us to find our semi-interquartile range, which we represent by SIQR, the semi-interquartile range, as you can clearly see, is half of the interquartile range. So whatever value we obtain for the interquartile range, it's just of getting half of that, half of 15, which will be equals to 7.5. And then in order for us to find the standard deviation, I told you we need to take the numbers. These are the 11 numbers, and we need to square each of them. So those are the square of each of them. 4 square is 16, the other 4 is 16, 5, 25, 6, 36, 8, 64, 9, 81, and so on. So if you notice, we have squared each and every single number within the set of observation. So this is it. Now we need to add all of these. From 16 all the way up to 625, we need to add them up. And that will give us the summation of x squared. So the summation of x squared, having add them up, will give us 2,327. So you can add that right now. After I'm finished with this problem, we're gonna end here for today because we only have 3 more minutes. So add from 16 all the way to 625, you should get 2,327. So you saw, did you confirm the value?
Yes, sir.
Okay, then we know that n
Yes,
is
sir.
11. Okay, we know that n is 11 too because 11 observations, and then the mean we obtained to 1 dp was 12.5. So all we need to do is to go and substitute into the standard deviation formula, the square root summation of x squared, which is 2327 over n, which is 11, and the x bar, the mean, which is 12.5 squared. So this is how it looks. Now calculate that from your calculator. Everything you could do in one day. I don't want to separate. Your calculator can calculate all of that, and you just put the answer. And this is the answer that you should get to 3 sig fig, 7.43. So do it and make sure you get 7.43. There are some calculators that you put the square root first and put in everything. It gives you answer. There are some that you have to do put in the other operation, and you have to put in the radicand first, and then you take the square root afterwards. But all of that can be done in your calculator. Tell me when you have obtained it. And when we are done here, you notice that we have like 30 more seconds. on my laptop says 12:59. No, it's almost finished. Anybody has got the standard deviation already? That's the answer. Make sure if you cannot use your calculator, use your calculator
Yes, sir, you get the answer.
until you get 7.43. If you get that, it means that
Yes.
you're using your calculator properly. So you said that
Okay.
you got it?
Yes, sir, I got 7.436, and the number continues.
Yeah, 7.4.
3.
Okay, good. And what come after the 3?
6, then 0.
6, then 0, which means then that to 3 significant, this would have been 7.44.
0.44.
Okay. We have other example here, but then time is up. Thank you for your time and enjoy the rest of the afternoon. Be safe and stay out of trouble. Okay?
Thank you, sir. Bye.
Okay,
Thank you, sir.
God
okay,
bless,
bye.
sir.
Bye, everyone. Nice meeting you today. Okay.
Thank you, sir.
Okay, you're welcome.